All right, good night. Good night again, everyone. This video is long overdue from the last video that I did online, which was, solving quadratic equation. I did promise that the next video that I would have done is matrices, you understand? And I haven't done it for this long time since the last video, so this video is long overdue. So welcome again, everyone, to this free maths class. It is a free maths class. As I often say, I am Mr. Williams, your maths tutor. Now tonight we'll be looking at a very special type of matrices question, which is actually using the matrix method to solve simultaneous equation. Why have I chosen this topic specifically in matrices? Because this topic is a compound topic. Sorry. It is made up of several other topics, you understand, which you will learn in the meanwhile. So therefore, covering this topic will cause me to cover the other simpler topics, them, if you understand what I mean. So it is compounded by other, I normally call them packet topics, or some fundamental principles that you need to know. All right, let's get into it now. So how to use the matrix method to solve simultaneous equation. Key prerequisite knowledge is very important. First one, student must be able to multiply a 2 by 2 matrix by a 2 by 1 matrix. Example, this is a 2 by 2, which means 2 rows horizontal and 2 columns. So it is a 2 by 2, 2 rows and 2 columns, right? And this is a 2 by 1 because there is 2 rows, 1, 2, and 1 column. So first and foremost, you must know how to multiply a 2 by 2 matrix by a 2 by 1 matrix. Now, let us quickly see if we can get a quick practice before, because remember it's a prerequisite. So let us put the 2 by 2 by the 2 by 1. Now remember now, with multiplication of matrices, the key is row by column. You know that, right? You must multiply row by column. That is the secret. Now, what do you do when you get a 2 by 2 matrix now? You multiply the first element in the first row by the second element, the first element in the first row by the first element in the first column, then the second element in the first row by the second element in the column. So for example, 2 by 3 is what? Or 2 times 3 rather, 6, don't. So that is 6, right? And 2 times 1 is how much? 2. So now that you finish row by column, you move to the second row now, right? First element in the column by the second element in the column. So look now, watch 3 times 3, 9. You will always have this video to go back to. And 1 times 2, 2. Right? So, and then now you simplify, you add. 6 plus 2 is 8. 9 plus 2 is 11. And that's the final answer. You understand? So that is how you multiply a 2 by 2 by a 2 by 2 matrix by a 2 by 1 matrix. 2 row, 2 column. 2 row, 1 column. Okay? And notice that you end up with a 2 by 1 matrix. Sometimes they will give you the matrix and ask you what is the order, what order it will come out with. So if this is a 2 by 2 multiplied by a 2 by 1, the first number and the last number, that will be it. So you're going to get a 2 by 1 matrix. You understand? Good. All right, moving on. So you need to know how to multiply a 2 by 1 matrix. All right, moving on. What's number 2? Number 2, prerequisite knowledge that you need to know, you should be able to find the determinant of a 2 by 2 matrix. Let A, so they normally label the matrix by any letter they chooses. Let A be this matrix. What is the determinant? How do you work out the determinant now? So let me get a page and show you how the determinant is worked out. So we say this matrix is it. So let A equal 3 and 2 and 2. Now listen carefully. These are called elements. All of them inside this parentheses is called elements. Now, this matrix of what is called a 2 by 2 matrix of what is called diagonals. Diagonals are always across. This diagonal that goes that way is called the leading or the first diagonal. And the next one that I draw in the green is called the non-leading or the second diagonal. So in order to find the determinant is normally like a DT shorten it with a, right? And it is normally the product of the leading diagonal subtract the product of the non-leading diagonal. So the product is what? 3 times 2 is what? 6. Remember, the product is always the result when you multiply, 2 or more number. You understand what I mean? So 2 times 3 is 6. Subtract the non-leading. 2 times 1 is 2. So the final answer is what? 4. 2 from 6 is 4. So that is the determinant. So that's how you work out determinant. Let me give you another example quickly. Let me use a different color to concretize. So you must know to find the determinant in order to use a matrix method. You understand, to solve a simultaneous equation. I'll give you another example. Let's say we use B. Give you a quick example. Let's say 5, 1, -1, and 2. It's good sometimes you put in some negative in it so you can get your practice with directed number. So therefore the determinant of B, right? What is determinant? Remember now, you multiply the leading diagonal first. So you say what? 5 times 1 is what? 5. And then you subtract. Now whenever, 5 times -1, sorry about that, is -5. 5 times -1 is -5. And then you subtract the product of the non-leading diagonal. Now whenever you have a minus right here in the non-leading diagonal, put your little bracket to guide you. So you say 2 times -1 would be -2. And look at this now. Negative times, remember you have to multiply the negative sign by what is inside the bracket. So negative times negative gives you positive. So therefore the final answer you end up with is -5 plus 2. And remember now you have two different signs. Keep the sign of the larger number. The sign of the larger number is negative. Then you subtract the small number from the large number, which is 2 from 3, gives you what? 2 from 5 gives you 3. So therefore the determinant, this is also used to denote determinant. Understand? That is also used to denote determinant. So the determinant is -3. Alright, good. So now that you know how to find determinant, the next criteria that you need to know is student must be able to find the adjoint of a 2 by 2 matrix. Now the adjoint is very easy. As you can see, example here, adjoint of B. Adjoint is the easiest aspect of it. Let me draw this back for you and work it for you so that you can see it's done. Okay. All right. Now let's say the matrix is B. Matrix B equal 3, 4, -2, -2. In order to find the adjoint, which is AD, shorten it, of B, what is very important is that you look at the diagonals them and make some adjustment to their diagonals, and I'll tell you what adjustment you'll be making to the diagonals. Now, for the leading diagonals, what you'll be doing, the elements in the leading diagonals, can you see? Very good. Which is this. The elements in the leading diagonal, you interchange their position, which means that 2 take 3 space and 3 take 2 space. It's done. Now for this, now the non-leading, you change the sign. So if this is negative 2, it becomes positive 2. And if this is positive 4, it becomes negative 4. And that's it. That's the adjoint. As simple as that. As simple as that. But can I quickly do another one just in case you're not sure? You always have it, can look back still. All right, let us use the letter C. So we say C, the matrix is this. Say negative 2, 4, negative 1, negative 3. That's the, and they've said find the adjoint. So the adjoint would be, you know, shortening for adjoint. Adjoint C. Remember, the first thing you want to do is what? Look at the leading diagonal, which is this one. Interchange their position. That is 4 take 3 space. 4 take negative 2 space. And negative 2 take 4 space. So we're done. And then for this now, we change the sign. This is negative 3. So it's going to be positive. This is negative 1. So it's going to be positive. And that's it for the adjoint. So that is all you need to know for the adjoint. You can always pause the video and write it off. So moving on. So what we're doing, we're running back through the basics that we need to know in order to use the matrix method to solve simultaneous equation. If you don't know these, you cannot do it, okay? All right, moving on. Now, let's see what we have now. All right, and the last one, I believe, let me see now, the last one. Yes, the last one before we get into action is that, as you can see, 4, what we have looked at just now was number 3. As you could have seen, see here, that was number 3 we have just looked at. Student must be able to find the adjoint of a 2x2 matrix. And the last one, student must be able to find the inverse. Here it is, the inverse. Let me kind of pull it up closer. The inverse of a 2x2 matrix. Now look at this. Given this matrix A, the elements 3, 1, negative 2, and 2. What is the inverse of the matrix? All right, so the inverse of the matrix is always 1 over the determinant times the adjoint. That's all. That's the inverse, 1 over the determinant times the adjoint. And since just now we have looked at how to find the determinant and how to find the adjoint. As a matter of fact, the adjoint was the last thing we look at. Determinant was previous. So let us know, right? Let us just work this out now. Sorry. Let us write back the matrix that we're given, the example. So what is it? Given A, this is the matrix. So we're writing it back over. The first thing you want to do, gentle beloved, is that you want to put your solution. You want to show them your solution sign, show them where you're going to start from. And if is it that they ask for the inverse is normal denoted by that sign. That's the inverse. And negative 1 at the top, okay? And the first thing you want to find out, what is the formula for inverse of a matrix? So that is 1 over the determinant of A. As I said to you, that it can be represented by these sign. This symbol, it is called the absolute symbol, or you just say enclosed by you know, two vertical lines. Multiply by the adjoint. Adjoint of a matrix A. So the first thing you want to do is remember how we find the determinant. So put your 1 over and work out the determinant down here now. Make sure you put your negative. Put your bracket like this. And put your adjoint to the side. First thing you're going to work out is the adjoint. The adjoint is the easiest thing, so work out the adjoint. Remember what you do in the adjoint? You interchange the what? The position of the leading diagonals. That's element 2, take 3 space, 3 take 2 space, and change the sign. So if this is negative in the non-leading, if this is negative, this is going to be positive. If this is positive, this is going to be negative. And you're through. So you're halfway through with the answer. Now what you're going to do, you're going to, for the determinant, you multiply the leading diagonal, which is 2 times 3 is what? 6. And listen now, negative 2 times 1 is negative 2. Right? And then now you tidy up. Put back here over 1. Look at this now. Negative times negative gives you positive. So therefore you're actually seeing 6 plus 2 is actually 8. and write back the adjoint as it is, and that is it. So therefore the inverse of A is 1 over 8 times that. You can sorry, you can always let me fix the camera. You can always pause the video and write this off. Always go back over it, right? So that is it for inverse. All right, I think that we can, so look at this now. So this is the activity. Find the value of x and y given the simultaneous equation below using the matrix method. Look at all these simultaneous equations. All these simultaneous equations that you're looking at now, they are all CSEC questions. CXC paper I took them from. So bear that in mind that these are actually CXC paper. So you'll be doing them. But first, before you need to know now, what's the method? What's the method? And that's what we're going to look at now. Here it is. Here's the method. So solving simultaneous equation using the matrix method. Key, the formula. What in simultaneous equation? Remember that you're normally solving for what? X and Y, right? So therefore, this is how it looks. The x and y is in column form equal the inverse times x. Now we know how to find inverse because I've just shown you how to find inverse. But we just need to know what is x. Now look at, so we'll know all of that. Example. Look at this matrix. This is a CXC question too, so bear that in mind. 2x plus y equals 3. 5x minus 2y equals 12. What is A and what is x? So we want to know what is A and what is x. So in order to get A, you need to extract from the two equations the coefficient of each value in a particular order. So notice 2 come right here, so the coefficient of y is 1, come right there, so 5 come under, notice 2 come under 5, and minus 2 come right here, so this is the order that they come in. Look at this order. 2 carry them down, 1 and negative 2 carry them down. X now I would call is the result. X is the result. So therefore what they're saying, if you're going to solve for x and y, maybe this is what, to be honest, this is what the book have to say. But since you're solving for x and y, I think it would be wiser that we use z. Isn't it be wise we use z then to say, yeah, z represent the result instead of x, since we're already solving for x. Don't. So if you do the book and they thought that you solve for x, you come to think about it, seeing that we're solving for x and y, it doesn't make sense that we multiply the inverse by x, which they said supposed to represent the result. Use a different letter. Use z. All right then. So z is normally the result of the matrix, which is z equals it here 3 times 12, which is a 2 by 1, and that is why in the beginning I told you must know how to multiply a 2 by 2 matrix by a 2 by 1. But don't worry yourself, we get into it. Sorry, moving on. All right, so teacher example now. Let us look at this one. Use the matrix method in order to solve this, right? The matrix method. Let's kind of put this one to the side. All right, now using the matrix method, what do we do? First thing you want to do, write a solution, as I've told you in time past. Show them where you're going to start. Secondly, write what is your formula. Remember, write out what is A. A is supposed to be the matrix, which is, notice 2 and 5. 2 and 5. Notice 1 and negative 2. 1 and negative 2. And Z is supposed to be the result. 3 and 12. That is the result. And what we're actually solving for is x and y. So therefore, x and y, the formula is A inverse times z. Makes sense. Instead I put x, if you understand what I mean. Now, let us work it out now. Let us first find the inverse. Sorry. How do we find the inverse, beloved? Recall that inverse is actually, so the first thing that we're going to do, I think that don't work it in steps because you might get confused. So this is what I'm suggesting you do. Find the inverse. What is the inverse? Inverse is always 1 over the determinant of A times sorry, the adjoint of A times Z. And we know, and let us plug in what we know. What is 1 over the inverse? Always put a minus sign. Remember that, beloved? You understand the adjoint. Work out what the adjoint is, because the adjoint is always the easier one. Remember, recall A, interchange the values. So negative 2, it come up here, so and positive 2 come down here. So and change the sign. So this should be negative 5 and this should be negative 1. So that is actually the adjoint here, and Z, we know what Z is already. So this is 3 and 12. All right, now what is the determinant? Let us tidy up the determinant now. Up here now, from A up here, that is 2 times negative 2 is actually negative 4, and 5 times 1 is actually 5. So you can say negative 4 minus 5 will therefore end up with what? Negative, you'd end up with negative 1 over negative what? 9 times negative 2, negative 1, negative 5, 2, and 3, 12. This represents X and Y. Now, listen now, beloved. Listen now, carefully. This is the key. This is the key. This is the secret. So I'm going to put some X around this. You see the aspect here? And the secret this now. You see what I'm going to teach you? When I'm going to teach you, trust me, you're not going to see it anywhere else. Okay? You see the aspect here are the secret. Hear what you do. Hear what is the secret to this aspect of it. You see when you come down here, so carry down back your X and your Y. Normally, you will be taught to multiply this by this, and then you multiply this by this. No, don't do that. You're going to confuse yourself. Remember, don't multiply this by this yet. No. Multiply these two first, and when you get your final answer, you multiply this. So here we do carry this down here so first. So you're not left it out. And then now, this is minus 9. Alright, it's the same thing. Let me cross this out here. So minus 9. Put the minus 9 down here, so alright? And then now multiply this 2 by 2 matrix by this 2 by 1, which I've taught you in the beginning. So let us take our time now. Remember, row by column. Row by column. First element in the column by the second element in the first row by the second element in the column. So let us go now. Negative 2 times 3 is what? Negative 6. Right? And negative 1 times 12 is negative what? 12. You're finished now, row by column. Move to the next row now. Negative 5 times 3 is negative 15. And 2 times 12 is plus 24. You see now? You see me there talk about? Carry him down now. Carry down back. You 1 over negative 9. And tidy up now. Add up this now. Look at this now. 6 plus 12 is what? Negative 6 plus negative 12, negative 18. Make sure you know a directed number. And look at this now. 15 minus 15 from 4. Keep the sign of the bigger number. Bigger number is positive. So therefore is actually 24 subtract 15 is the same thing, which is 9. Now you can multiply this by this now, people. You see how easy now? No confusion. If you tidy up the answer. So see it here, negative 18 over negative 9 and 9 over negative 9. So the final answer would be negative divided by negative is positive. So 9 into 18 goes 2 times, and negative divided by negative give you negative, and 9 into 9 goes 1 time. As simple as that. Just see it here, pause it. Add you multiply this is called a scalar factor. Had you multiply this by here, so like how you'd have been taught, it can cause a whole lot of confusion. So what I'm suggesting is that you multiply it like this first, carry down the scalar down to the last, and then you multiply by the result. Alright, so that is it. That's the teacher example. So I'm going to give you some time to record it. See it here. This is the final answer. As simple as this, as I said. This is a very important step. Moving on. So that is it. Let us move on to another patient. This is another teacher example. I'm going to work one more before you, and I'm going to give you a chance to work one on your own, because I know by now you're saying, sir, can we not work something for ourselves? Nevertheless, you can pause the video right now, pause it right now, work this out, and then you come back and watch the teacher example. All right, now, ready again. Now, ready again. Bam, let us work this teacher example, this last one, and I'm going to give you your homework, right? Do it yourself activity. Yeah, definitely. Let's just look at this teacher example. First thing you want to write is a solution. I'll work this quickly. Write the formula, which is x, y. This is what you're solving for, and a is equal to, write out 1 and 3. 1 and 3, that is the coefficient before the x term, coefficient before the right term in the same order, 2. And what is before the right term? 1. And remember, what we use for the result is z. It makes sense that we use z instead of x. Good. Write out what the formula is now. So x, so we'll come down, we'll reason with them. X equal a inverse times z. We know how to find the inverse already, the same order, right? What is the inverse? Put it 1, put your minus sign, a 1 minus. A work out now your adjoint. You put your adjoint of a, and then you put a z. All right, good. Let us continue now. Working the inverse. What is first, as I told you before, work out the adjoint. The adjoint is the easiest thing. So for the adjoint, you interchange the leading coefficient, leading diagonal. So one take one space and one take one space. So you interchange. Oh my, me have to laugh. And these now, you change the sign of the non-leading diagonal. So this is negative since it was positive, and this is positive, so it becomes negative. And then now you write back what the result is, which is z, 8 and 9. Now let us tidy up now the determinant. So remember, you multiply 1 times 1, 1, and 3 times 2, 6. So therefore 1 minus 6 is minus 5. So therefore we're supposed to have 1 over minus 5. And then now, remember I said now, what we're going to do, we're going to multiply. We're going to carry this back down. Yeah, carry this back down. Yes, 1 minus 2 minus 3, 1, and 8 and 9. What take with time? We're not rush the process. So this is actually x and y. What do we do from here? So here says the important aspect again. You don't use the 1 over 5. You don't use a factor. So make sure I highlight it so you can see it. You don't use a factor, this to multiply this, and then use this to no, you multiply this first. So carry down the factor, which is 1 over 5, and then you do your multiplication. Now you know how to multiply a 2 by 1 matrix by a 2 by 2 matrix by a 2 by 1. I teach you that from the beginning. I'm a worker example. So look at this now. 1 times 8 is what? 8. Negative 2 times 9 is what? Negative 18, don't? And then now you have negative 3 times 8, which is negative 24. Make sure you know your timetable. And 1 times 9 is plus 9. Now we can tidy this up. Carry this back down here. So 5. Carry it back down. So this is x and y. Tidy this up now. 8 minus negative 18. Keep the sign of the bigger number, which is negative. Subtract the small number from the big number, which is 5. And look at this now. 9. Keep the sign of the bigger number. Subtract the small number from the bigger number, which is 15. And then now, this is where you multiply now. So that would be negative 10 over negative 5. And negative 15 over negative 5. Make sure you see what I go on. And the final answer would be what now, class? When we simplify now, a negative equal negative into negative give you positive, and 5 into 10 give you 2 times, and 5 in negative into negative give you positive, and 5 into 15 give you 3. So that is the final answer. If you want to be sure that the answer is right, you can also substitute the values that you get for x in the most appropriate equation, and if you get back the answer, you know that you are correct. For example, we get what? We get x to be 2 and y to be 3. and y to be 3. Now using the equation, let me show you the equation. Using the top, which would be more easier to use, let us substitute the value. If the left hand side of the equation equal the right hand side, then we know the values are right. What is x? 2 plus 2 and 3. If this side equal 8, we know, watch you now, 2 times 3 is what? 6 equal 8. See it here? 2 plus 6 equal 8 equal 8. So also sometimes you have to know if you test your answers to know if you are correct. So that is it. The video kind of lengthy, but you know, say we always walk you through the fundamentals before anything else. So right now I'm going to give you a do-it-yourself activity. I want you to do this, post it in the comment section what you get for your answer. And for your homework, this is your homework. This is your homework. Can you see it? So that is your homework. Pause the video. And up next is part 2, which will be looking at a different kind of matrix question. You understand? Example. You see now they give you 2 by 2 matrix and they give you some letters inside like K and B. And they ask you what is K, what is B. Please remember to subscribe, right, for the next video. Okay, please enjoy the rest of your day. Remember to like, subscribe, and share. Okay, all right.